Going
Get it
live.
out of my system.
Sometimes you'll make it home, y'all. They're wasting. No one can make it go away.
All right, welcome everybody to another edition of Ms. Bomey Zone. See, I got that right. I didn't say the wrong name. I was worried. Can you hear me all right, Christine?
Yeah.
Okay. Got Dr. Mark with us again, everybody, and we're going to be doing black holes. And I got giddy all day when I was studying this. So I'll turn it over to you, Christine, to get us started.
Well, hello, everybody. Thanks for joining us tonight. As you know, we do have Dr. Mark with us, and we're going to talk about black holes. I thought this was an interesting topic because there was a documentary on the Science Channel not too long ago, and it really piqued my interest. So I wanted to say thank you, Dr. Mark, for joining us. I'm sure that John and I have lots of questions for you this evening.
Okay. Glad to be here.
Yes.
So I'm going to start off by saying thanks everybody that is listening tonight, that will be listening in podcasts maybe later on. Our topic tonight is black holes, of course. So let's get things started and explain to everybody out there that maybe is not like really into science, like, can we get like an overall idea of what a black hole consists of, so we have kind of a starting point, and then we can kind of go from there with maybe some questions and whatnot?
Well, the simplest explanation, most black holes and all the ones that we can see are stellar. Basically, they come from old stars. A star at the end of its lifetime will quit giving off enough energy to be able to hold the surface out, and the massive gravity of the star will cause it to collapse. Above a certain size, those stars will go supernova, type 1, 2, or 3. When they explode, they blow off most of their mass off into space. Some of that mass comes crashing back. In the case of most stars, the ones the size of our sun and so forth, they form what's called a white dwarf. If they're a little bigger than that, say around 10 times, then they have enough mass and they collapse all the way back to what's called a neutron star. The neutron star is heavy enough that all of the electrons and the protons, the two basic parts of an atom, are pressed into each other and they become neutral. The plus and the minus cancel each other out. Those are actually fairly small. They can be anywhere from the size of the city of Manhattan in diameter to about the size of the Earth. They're not real big. You go much above that, and depending on who you talk to, somewhere between 10 and 25 times the mass of our sun, up to about 100. When it collapses, the gravity just keeps it collapsing down and down and down. And it actually collapses into what we call a singularity. And the mass is great enough that it causes a basic collapse out of our space-time. There not really being a better way in English to put that. Mathematically, it's not really correct, but it's poetic anyway. That is what we call a black hole. A black hole, basically the black hole itself has collapsed down so small that it's what we call a Planck length. P-L-A-N-C-K. Max Planck was a physicist mathematician a century or two ago. And he theorized that this would be the smallest possible diameter of anything. The actual size of the actual black hole itself is around 10 to the minus 35 meters. So a 0.0, 35 zeros and a 1 after that. That's pretty darn small. It'd be, say, 14 trillion times smaller than an electron, which is pretty small. The black hole, however, continues to have all the gravity that all the mass that collapses into it. So anything that comes close to it is going to be trapped.
Mm-hmm.
It can actually fall into the black hole and disappear out of the possible realm of this universe. It can go into orbit around the black hole very tightly, because if you think about it, you're trying to put a whole bunch of mass down through something that's the size of a Planck diameter, which is that small. So that's kind of like a clogged up drain, if you will. So that stuff, no matter how good your gravity is, can't get through the black hole. so it tends to hang around the outside. And most black holes spin because the sun they came from was spinning, so they maintain that angular torque, if you will, that angular momentum that continue to spin. So if a black hole spins, the stuff coming into it is going to spin. It's what we call an accretion disk. The things you see around the out of the black hole, what you're really seeing is not black hole or anything that is falling in, the stuff that is about to. And all that stuff flies around the outside, rubs up against each other, speeds approaching light because of the immense gravity. It gets very, very hot. We're talking millions of degrees centigrade. And from there, it releases a lot of energy. So what we see and the way we know about black holes, basically seeing the accretion disk, because you've never seen the hole itself. And what we think we know about them from observation is how we see it react with matter, other stars, anything else that might be around it in their universe. So that was longer than the short explanation. Sorry about that.
No,
anybody
that's
hasn't
okay.
really looked at it,
No, I think it's a good explanation, and it gives everybody a good starting point to give an idea of what the black hole is and what it could possibly do. So it's very, very interesting doing some of the research. Now, you talked about like different sizes of black holes. Some are stellar, some are supermassive. What is the difference between some of the sizes of the black holes in general?
A stellar black hole would be down toward the lower limit of the size of a star it would take to form a black hole.
Okay.
So somewhere at least 10 and maybe 25 up to around 100 times the mass of our sun would still be a stellar black hole. In other words, it formed from a star. It's sitting out there all by itself.
Mm-hmm.
A supermassive black hole would either be several of those that have run into each other, or, and this is where it gets very interesting, the ones at the center of our galaxy, and as far as we know, at the center of all the galaxies we can see. And the reason that's interesting is because there now is a lot of speculation and some evidence that except for that black hole, we wouldn't be here. We literally owe our existence to the fact that there's a supermassive black hole in the middle of our little island galaxy.
That's good you said that because
Now, those are going to be on the order.
I wrote something
Go ahead.
down. I wrote something down about that. I'm glad you said that because I went through this whole beginning thinking black holes were drawing in stuff, and it actually apparently is not the case. They don't like suck in stuff.
Yeah.
And the interesting
like
thing
a vacuum
was,
cleaner.
yeah, the thing was really cool was they said if you took a black hole with the same mass equal to our sun and you just put it there, that this Earth would not be drawn into it. It would continue to just follow its path. We would follow our same path.
Yeah.
We wouldn't be drawn
into it. We'd get real cold, but
we'd freeze.
Yeah, exactly. Gravity would be exactly the same.
That's the part that I found funny.
Well, mathematically, here's a really funny thing about it. Black holes, okay, if you take two pieces of clay, each one is 4 inches across, and you mash them together, and you form another sphere, you don't get an 8-inch sphere. You get one that's only a little bit larger than the original 4 inches because that's just the way diameter works. You have double mass. It weighs twice as much because you got twice as much clay, but you don't have twice as big a ball. All right. That is not true of black holes. Every time you double the mass of a black hole, you also double what we call the Schwarzschild radius, which is how big the black hole is. So here's an interesting little thing astronomers like to mention as a paradox. If you filled all of the inside of the orbit of Neptune from the sun to Neptune with air, it'd be a black hole. It wouldn't be what you and I think of as a black hole, but because the diameter grows so much, that much air would be a black hole. It's weird, but it's true. They've worked out the math on it. I'm going, okay, that's totally counter to everything we visualize when we think about a black hole. But it happens to be right.
Well, that's
and it would have the same
concept.
mass. I mean, Yeah,
and
kind of weird.
the thing that I thought was crazy also was, it's hard. You can say it and you hear the words come out, but when you stop and start to think about it, then it really gets weird
Yeah.
because
Uh-huh.
it bending space around itself is the part
Yeah.
that if you understand how if you think about it, understand how an airplane flies. All right, you have air passing under a wing at one speed and air passing over the wing at another speed. So
Right.
that's gonna happen if you're actually bending space around a black hole. That's gonna happen. It's gonna go on one area faster than the other, which means by default it would actually be changing time.
It does. The area around Cape, let's define a couple of terms. The Schwarzschild radius is the outside rim, if you will, of a black hole, even though there is no such thing as a rim for a black hole. But it's the diameter of the black hole. And outside the Schwarzschild radius is what we call the event horizon. You pass the event horizon, you've now gone into the black hole.
Mm-hmm.
Around the event horizon, however, is a thing called the ergosphere. And the ergosphere is an area where the massive gravity of the supermassive black hole especially has warped the very fabric of space. We're talking Star Trek level weirdness here. It has actually taken space and wrapped it around itself. Think of a drill where you get a piece of cloth caught on it, and it's whipped around the drill bit really, really fast.
Mm-hmm.
It's actually dragging space around itself in exactly the same manner. So that space is not really the same as ours in space-time out here. If that was your time, it'd be a yanking, but you're not spinning it. You're just, and that's the way it would be if you got very close to it. The ergosphere is being pulled so hard by the gravity of a supermassive black hole that the actual speed of objects inside the ergosphere is, compared to us out here, faster than light. So if you were one of those objects that has not yet gone to the event horizon, you're being pulled to the ergosphere, you'd still maintain yourself. You wouldn't have undergone what the astronomers call spaghettification yet. But you wouldn't be able to see anything because you're traveling faster than light, except for what's in the ergosphere with you. And there's only three things you can do. Try to get out of the ergosphere, which might not be possible because of the gravity. Go closer into the black hole, which is sort of inevitable. That's what's going to happen to you anyway. Or be able to spin around the outside in sort of a stable orbit. And that's probably highly unlikely. So you're toast. But nobody's ever gone into an ergosphere to find out yet. This is just a theory, but when you have something massive enough to warp space-time, this is where the outlandish concepts people get from movies like Interstellar, which says, if we understood how space-time is being warped, then couldn't we use it for various things like travel, faster than light? Could we use it for time travel? Could we use it for any number of things?
Well, yeah, it just seems like,
and that's why those things are actually not impossible.
But yeah, it would seem that if there was a way to stay back enough where you could actually not be, if the event horizon or whichever one it is you were just mentioning, where I go past that point, now I'm in trouble. If you were able to stay on this side of that particular trouble, you would be able to essentially move through time quicker, move through space quicker, and come out the other end, but have traveled the same distance that it would take X amount of time to do, but you would have done it far faster.
If you're moving faster than light is out here to the rest of the universe, then you're right, how else would you define time travel? That's actually a pretty good way to do it.
Yeah. I just thought that was crazy when I'm sitting there looking at it, going, well, wait a minute. Because you look at diagrams, and they're showing you diagrams, and that, if you had a piece of wire stretched, it's exactly the distance from where you are right now to Earth. When a black hole came between you and Earth, you need a hell of a lot more wire all of a sudden. You need a hell of a lot more wire. You're like, well, wait a minute, but that doesn't make. But then you start to see what they're showing you is how it's bending time around itself, and you're like, wow,
right,
okay. And then you see, as I saw the one that had rigs on it, they were showing it with lots of rigs, and rigs going down into a tube. But then there's this one section where that rig is so small, and that's the spot where I was going, well, wait a minute, if you were from there to there, you've cleared the same distance as going around the entire black hole. And you're on the other side. You're on the other side now, so you could essentially go that far, and you've just traveled through so much space and time. I mean, holy crap! I just thought that was insane.
It is, and sure, it'd be nice to be able to study one a little closer if you could survive the experience.
One day.
One of the things a minute ago, Christine, you started to allude to, or started to ask a question, I think, was about the supermassive black holes at the center of galaxies.
Mm-hmm.
Okay. One of the interesting things, let's back up a little bit. You were asking to define a black hole. Let's define something else that we've noticed for a lot of time. I think since 1940. It's called a quasar. A quasar is a quasi-stellar object that emits radio waves. Well, it turns out they don't all emit radio waves,
Right.
but they all do emit a lot of energy. Well, if you have a rotating accretion disk that is all grinding against each other at several million degrees centigrade at very, very high speeds, that's a lot of energy. Well, because it's rotating, it tends to focus that energy along two axes. Let's call them the North and South Pole. The North and South Pole of a quasar, which is a whole bunch of stuff around a black hole, puts out trillions of times as much energy, in many cases, as one sun does. That's an awful lot of energy, and that's what made us look like it. Some of these things are brighter than a whole galaxy. Now, the reason we don't see more of them is because we're looking at the ones that are pointed more or less toward us. If they're pointed sideways, you'd never see it. You don't see a beam that's not aimed at you. It's like a flashlight not being near you.
Right.
All right. If you think about that, what happens when finally, over a long period of time, all the stuff that can be sucked into that particular black hole has been sucked in? That's quiet. It's a vacuum around it. Your quasar disappears. Black hole's still there. Gravity's still there. But there isn't anything falling into it anymore. So quasars apparently don't last forever. They just last as long as it takes. The really cool part is you can reactivate one if all of a sudden some more mass becomes available. Now, if you're in the middle of a galaxy as a black hole, presumably you've eaten all the mass that there is to eat for that galaxy. Now, maybe it's still going and you have a quasar in the middle of the galaxy. Maybe it's not, and it's quiet and dark. But the whole point to all this is they spin. There's no other way to account for the shape of a lot of galaxies, especially spiral galaxies like ours and Andromeda, except for the fact that they were, if you think about how the solar system formed as a spinning disk that coalesced into planets, well, this was a spinning disk that coalesced into stars. And eventually, the one in the middle, so if you think about it from the point of view of vortices in a pond, all that stuff's just going to float out there and kind of, stay homogeneously more or less the same density. It's not really going to clump together. But you have an influence in the middle, like a black hole that is spinning, it's going to cause them to start to clump together. When they clump together, they become more massive. When anything becomes more massive, it starts to move. If you're spinning a small ball around your head and then you start spinning a bowling ball, you realize the heavier one wants to yank itself much further from your hand as you're spinning. The same thing applies in this case. The stars are going to be pulled much further out there. And eventually, they're probably going to form spiral arms, pretty much like we have. We would not have the stars coalescing and the spiral arms of the galaxy forming without some sort of influence. And there's a pretty good set of theories that say more than likely it's because of the central black hole in the galaxy that we exist.
No,
Everybody thinks of it as a destructive force. Now it's a creative force.
As a matter of fact, one of the things I was reading about that was, what's his name? Shoemaker, is it? Is it Shoemaker? I think it's Shoemaker. Was talking about there was a detection made like a year and a half ago. I think it might have been 2 years ago. They've discovered that there's gravitational wave observation or whatever the heck that is. They said these stellar black holes are gathering together apparently, and it's becoming a stellar mass black hole, I guess they call it, larger than 20 of the solar masses. So I thought I was like, wow, when you were just mentioning that, I was like, oh yeah, hold on, I gotta find that note there because that's actually creating from a black hole.
Yep, exactly. And yeah, David Shoemaker was the one to talk about that, and he got this from evidence from neutron stars. Did you see that part?
I saw a whole bunch of it. I just wanted to highlight that though, because I was like looking at things where
Oh,
I
yeah.
was start. I had a note that said, changing my mind. I always thought, I'm one of those people who thought that black holes were like giant Hoover vacuum cleaners, and they just sucked everything around them.
See, yeah.
And so
I think
I
that's
so I
everybody's.
wanted to stop for a minute, and I wanted to do some studying, but teach myself you're wrong on this, but now show myself why am I wrong. And so one of the notes I had was that there's many people that believe that they're actually building blocks. So I started looking for those
Yep.
particular things, and that's when I came across the article from David Shoemaker.
Kind of makes you wonder if there's a real plan in the universe here. Like black holes actually cause the formation of galaxies. Now, if you think back to the original Big Bang, there was a lot of whirlpools or vortices that are among the matter that's going out. In other words, they're very localized, very intense gravitational areas. The thing is, more than likely, some of those form the third category of black holes, which are called micro black holes. Now, they don't need to be very large because they're not forming from a collapsed star. They're simply forming from a whirlpool, if you will, like on the side of a stream.
Okay.
Only you were talking stellar objects in the Big Bang, so that's moving pretty quick, and that's a lot of gravity and a lot of speed, or it could be faster than the speed of light in some cases, because the physical laws in the first few microseconds after the Big Bang didn't really settle down. At least that's the theory we think of now. So a micro black hole could exist almost anywhere. And a micro black hole is going to eat things around it. So if it does exist somewhere, could that be the reason all the little micro black holes grow to be bigger black holes, and those eventually became the supermassive ones at the heart of a galaxy?
Yeah.
Because after all, why would all that disorganized matter from the Big Bang decide to organize itself into galaxies?
See,
why wouldn't it just be?
That's one of the points I always wondered why people that, now when I say this is, so you make sure you send me your hate mail, folks. I always wondered, people that are religious, all right, that are incredibly religious, and they believe in one method, one thing only, okay, why they can't embrace the Big Bang Theory. So I always wondered, because the statement of "let there be light" looks an awful lot like a Big Bang to me. Just that statement, okay? And then instantly creating the heavens, that kind of would follow the same thing when you think of, they actually describe the speed, I believe it's called Planck speed, as the speed of God, right?
Mm-hmm.
So, I mean, I always wondered, why don't they embrace this and at least learn more about it? I always thought that was, because I come from a family that, lots of religious in there, and they fight this with everything they have. Everything they have, which made me want to go learn about it, because I always thought, geez, I think I would study more about it and learn more. Because to me, it seemed like if you were really religious, this would be a great way for you to prove your point.
Yeah. Well, the whole thing is, people are comfortable with what they know. They like to hide behind things to avoid discomfort and things that scare them. And science has always scared some people. So why not go ahead and follow your instincts and bury your head in the sand, which is what a lot of them would rather do. And if they can bury their hand in the sand while pointing a finger at you and calling you either a heretic or a blasphemer or something else, then, so be it. It makes them feel better about themselves. It doesn't make us feel better if they hang us or burn us, which has happened a few times.
Well, very, very true. I just always found that very odd. If I was teaching a flock, I would want to be actually using science on my side, because then I'm going to have a much better chance of explaining what I'm trying to talk about.
Now you're totally escaping the main thrust of the idea that science requires study, scholarship, and an investment of time, whereas faith requires you to put something in an offering plate.
Correct.
Now, somebody's going to write me some hate mail about that one, I'm sure. The whole point is, hate's easy. Science is hard. I mean, it takes a while to pick up this stuff. It's going to require you several years of your life and an open mind, which they started with a closed one. They're not going to get there.
Bearded
But
CB
let's go
just
back
made
to
it
something else.
real quick here. Bearded CB's in the chat.
Supernatural.
Bearded CB's in the chat room. I want to mention it real quick.
Cool.
He made a very good point.
Good.
He said, "Who
Go
lit
ahead.
the match?" is always a great question in the Big Bang Theory, and that's what
Well,
I'm
that's
talking
my question.
That's a very good
It
statement. right
had
there.
to start somewhere. How or who or what started it?
That's the part that I'm always amazed is why don't people embrace it more? Because I'll tell you what, when you're walking around saying no, it was instant, it was just like there and there it was. If you embrace the Big Bang Theory, you can go see, and there's the proof of it. See, 1 minute it wasn't, next minute it was. It fits everything. It fits everything because there was nothing there but void, and void got so compressed it became something. So I mean, yeah, it sounds pretty much like what they're talking about.
Here's another possibility. One of the things Christine alluded to earlier was the fact that it basically takes things out of this space into another one. There's another school of thought that says, where does that matter go? And that there are things called white holes. And a white hole is simply a black hole looked at from the other side of space-time.
Okay, now
Where does all the stuff that goes into the black hole come out of?
Oh. So is that kind of like
Now he's freaking me out.
Conservation of
giant-
mass and energy.
There's like a giant
that-
bag somewhere on the other side of space, and they're going, "What's with the giant bag?" And they go, "Well, that's the white hole. That's the big
so it's
trash."
like
That's right.
looking at the flip side of a coin,
Yeah.
in a way, right?
That
Or
could
am
be
I
the
not?
Big Bang.
Okay.
What's wrong with that being the genesis of the Big Bang?
Yeah, that's. I've always been amazed. I've always, I don't know. It's just always amazed me. I've given my father grief about that too. I've said, you know what? I don't understand. I don't understand how you try to teach everybody that there was nothing there. Do you get it? There was nothing there. Then all of a sudden, the statement was made, "Let there be light," and then everything just happened all at once. You're like, that's what I'm talking about. That's what we're all talking about. It's the exact same thing. I just never understood why I could never get him to understand that.
One thing
You ever
that I
wonder-
found interesting, if I can just say this, is that when I was looking into this, they say that you can't directly see a black hole.
Right.
Why is that?
The escape velocity out of the black hole is greater than the speed of light.
Okay.
So nothing, including light, can escape from a black hole because nothing can travel faster than light in its own reference plane.
But wouldn't
So
you be
light's
able to
not
see
gonna-
it passing in front of other stars? Have a black
No,
hole?
it's still inside. It's within the event horizon of the black hole. So therefore, there's nothing in there but, the singularity itself, the black
No,
hole.
what I mean is if you have a black hole that's in an orbit. Okay, here's a black hole in an orbit, but now you're looking at a much vaster space from a greater distance away. Would you not be able to detect that orbit as it moved? Because it wouldn't be
Not
sucking
really.
away stuff from way behind it, but it would be passing
It
in front of
should.
that.
It should, except for a little Einsteinian experiment he did in 32, I want to say. He went to South America, and he said, light has no mass. Therefore, light should not be subject to gravity. Therefore, light should not be bent around gravitational objects. So they went and looked during an eclipse in South America at light coming from some fairly distant star, and they found out that light gets bent around a gravitational field. It's called the lensing effect. Well, the black hole is the ultimate gravitational field. So it seems likely that light going past the black hole would just get bent around it, and you'd see light from the other side.
But
Think of
would
it
you
as reverse camouflage.
Right, but wouldn't you be able to see, though, that distortion? There'd be some sort
Oh.
of distortion, a disruption around that event horizon? Is that not viable?
The feeling is not really. Depends on how big it is. For one thing, how are you going to see the distortion if you don't know it's being distorted? In other words, anything that's behind it, you're saying it goes around in a circle and comes out in front of it. Well, you haven't measured how fast that light's going.
Oh,
You don't
right.
know whether that was this photon just now or a photon that came out 100 years ago and it accelerated, or one that came out yesterday, or whatever. It's still going to get bent around it. In other words, you can't measure the speed of where it came from because that star is too far away. Yeah, there would be a difference in the time it took that light to get to you, but it's steadily emitting light. Unless you had it blink on and off and then measured when it blinks on and off, which is hard to do for something 100 light years away.
Right, but I mean, I thought like maybe within our own solar system, if there was something like that, if there was a way to see, but because they've found things before in that same principle where things have passed in front of, and they've discovered that happened, and maybe if something's in an orbit, like a black hole is in an orbit, and it's following a certain path, they might be able to study it, or they might be able to see that something keeps happening as a result of this. I just thought my brain was. Go ahead.
You got to remember that the singularity itself is Planck size, 10 to the minus 35 meters. That's so small that it would be pretty tough to tell if it was passing in front of something or not. I mean, the likelihood of something that small actually passing between you and one of the multiple points of light in the sky, whether it's a planet or a star, pretty slim.
Yeah.
Now, on the other hand, if it had mass around it, you could track it by its accretion disk. That'd be obvious. That'd be large, loud, noisy, and bright. It'd be hard to miss. Speaking of it pulling things in, have you heard of zombie stars?
Didn't get that far.
I saw something about it, but I didn't really dive into it because it didn't grab me for some reason.
Here's the theory. A neutron star is dead. It's as dead can be. It's the old star. It's died, and now it's got no charge at all. But they do happen to have, believe it or not, a liquid core. Even though their mass is several million tons per square inch, it's still a liquid core with a tiny crust on it. If you got one, they don't have any more hydrogen or helium to burn, so it can't use the solar phoenix effect that our sun and all the other stars we think use to make light and energy. But if it got next to a black hole, all of a sudden that massive gravitational tide from that black hole would disrupt that neutron star enough to cause it to actually burn again. It would make a zombie star out of a dead one.
Huh.
That's actually the prevailing theory. And I went, wow, zombie stars.
So
now, it wouldn't last long because in a few fractions of a second it gets sucked into the black hole more than likely, but still.
So
kind of interesting to think about.
I have a thing here written down that I wrote that says black holes can generate energy more efficiently than our sun. I thought that was an interesting statement, and I put that down. And it says scientists have proposed that this type of energy, this is the type of energy that could be used to power a starship in the future.
Sure.
Now I didn't
Okay.
I didn't write enough down. I was interested in it, but I didn't write enough down, so now I'm not really sure what type of energy that was again.
It kind of goes along the same line of a warp drive and dilithium crystals. We don't really know how that works either. Gene Roddenberry didn't go quite that far and tell us. But the deal is, speaking as a propulsion chemist, if you will, I've got a little experience with some rocket fuels. You're looking for something that has an efficient conversion to energy that does so without us having a whole lot to do with it, heating up things to an immense temperature and out the back of something give us, basically what you're doing to get a spaceship to throw faster, you're standing on the back throwing rocks. As you throw them away, the spaceship moves away from which way you threw the rocks. Well, think about that as rocket fuel and you get a little better thing. Let's assume you got a black hole. Black hole is capable of heating things up to multi-million degrees centigrade.
Okay.
Seems like a reasonable start to me to a spaceship drive. And you got, there's nothing in there to stop you from doing it. In other words, you don't have to put any energy. There's no investment on your part. You simply put your little tame black hole there and put stuff near it and let your accretion disk do all the work.
That'd be insane. Wow.
To harness that energy, yeah, that's crazy.
Okay, one of the things that I thought was interesting, and this is where Stephen Hawking had to back up, which was one of the few times he's ever admitted he was wrong. And that's that black holes, we thought, okay, well, black hole just sits there and sucks and sucks and sucks forever. It's the Hoover vacuum without an off switch. Turns out not to be true. If black hole is inactive for a certain amount of time, it dies. It evaporates. Now, you got to think, how would a black hole evaporate? Because it's sucking stuff in, matter. So eventually they came up with an interesting idea, and it's actually called Hawking radiation. If you look up a concept called black body radiation, there is, you can't see because it's not visible. There's actually thermal radiation put off by black bodies. We did this to account for the fact that we're receiving radiation from places that didn't shine like stars and wondered why. Well, a black hole can do the same thing. It puts off black body radiation. And over a period of time, even a supermassive black hole can actually evaporate back to nothingness.
Now, in that same question, if it evaporates off to nothingness, okay, it lies dormant just because my brain is my brain. Now, we discussed the reverse side of the coin, the possible white star, right? The white hole. Matter that's been pulled in, okay, or that's been flung in, however you want to describe it, drawn in through its gravitational pull. What happens to that matter?
Good question. I don't think that anybody has ever come up with a reasonable answer, or even an unreasonable one. The fact is, they just simply don't know. It basically disappears from this space-time. That's all they can say.
So the principle of teleportation
That's a highly
is true.
unsatisfactory answer.
So then that would make teleportation a true principle. Then. Because if it went in and it never comes out, it teleported somewhere else.
Right. Well, maybe teleport is not really the right one. I always think teleportation is something you can survive. But
true, very well. It went somewhere. They're able to send it somewhere else. Then I mean, that just freaks me out. It's like if it goes in and it never leaves, but then it evaporates and goes away. Well, there's still a whole lot of stuff.
Well,
that went somewhere. I mean, if it evaporated away and there was a ball of super ultra denseness there, okay, I could digest that, understand that. But if it's just gone, then that means tons of mass, millions upon millions of tons of mass went in, never left, and then it was just gone.
Well, let me tell you a theory. And this theory is written by a gentleman named Stephen Hawking. It's called conservation of information. If you think about teleportation, you'd have to break whatever you're teleporting down into transmissible information. You're not actually taking the actual protons and electrons that make up the atoms in your body and shipping them off somewhere. What you're doing is you're taking the information about the relationship of all of the atoms in your body, and you're sending them to something that's going to reconstruct you, if you will. So the teleportation device uses whatever matter is handy. It's kind of gross if you think about it, because you could be made up of you right now. When you get teleported to LA, you might be made up of a dog crap that it uses the nearest stuff to be able to replicate you.
Yeah. Now here's
one of the interesting parts of science fiction.
Here's a little scientific experiment for you. I was doing this with a guy a long time ago. We were talking about teleportation. He was like, well, we cannot survive. He mentioned surviving. You can't teleport a person that can't survive. You can't teleport a plant. You can't teleport any living organism, but teleportation can be done. I'm like, what? He goes, it can be done via light. And I'm like, what? He goes, yeah, I'll show you. And he did an experiment with me, which blew my mind, by the way. He said, we are going to take a radio conversation. We're going to take a conversation, and we are going to teleport it from one area to another area, not using radio waves. We are going to use light. We are going to transmit an entire conversation via light. And I was like, that's the first time I'd ever seen it done. So he did the experiment with me. And it's pretty simple once you start going, you know. It's just pointing a laser at an obstacle, at an object somewhere. Like, say you have a window, and there's a special cup that goes on that window. You point the laser at that, and now you can hear, you're teleporting that entire conversation back to you via the light. Not using radio waves, not using any transmitter or receivers. standardized transmitter receiver. So I was like,
Cool.
wow. He goes, so that is teleportation, he said. But now we can't do living things. And I was like, what? I was just blown away. I was like, are you kidding me? And I started studying about that. I was like, and believe it or not, they're able to actually have light traveling in a direction, but have a conversation come back down that beam of light.
Yeah,
which I
true.
thought was pretty amazing.
There is a observatory in the British Islands that has already done quantum teleportation, and they've done it by a very interesting method called quantum entanglement. And they have proved that you can send something. I believe their current record is 37 miles, but they sent information 37 miles via quantum entanglement from one island to another around England somewhere. I'm trying to figure out where it is. That's pretty close to teleportation. But no, to answer your question, Hawking's idea about what happens when something hits a black hole is called conservation of information. Actually, I call it that. I'm not sure he ever did. But this sounds more like Steve Jobs than Steve Hawking, but it really is true. There's a thought that anything that gets torn apart at the event horizon of a black hole leaves an image. Hawking thought it might be like a hologram of the information that it used to be. An analogy is if you take a book and burn it, the matter that book was composed of is still there.
Yeah.
It's just not very easily readable, but it's still there. If you were good enough to backtrack the matter, you could recreate the information that was in that book even after it was burned. Okay, same thing probably happens at a black hole, according to Stephen Hawking. Stuff hits the edge, and there is sort of, if you will, a quantum pattern on the event horizon of the black hole, which gives you the information of every piece of matter that ever fell into that black hole. Sort of a library, if you will, or probably should say library card system, if you will.
Yeah.
Now, where does the matter itself go? That's still something that even Stephen Hawking didn't have at hand.
I've actually done that experiment where you write, watch this in ink on a piece of notebook paper, and you lay it on the coals of the fire. And it burns away, and when you're done, what do you see looking at you? A piece of paper that says, watch this.
Right.
You can,
exactly.
you can, and for anybody out there, try that. Try it sometime. You can actually write on a piece of paper, lay it on the coals, it'll burn up, and you can still read what it says. You know, if you laid it out there right before the wind hits it, or the thermal, waves knocking away or whatever. For that moment in time, though, you can still read what it says right there. It's all still there.
Absolutely. Can't get much cooler than that. So,
It's pretty interesting.
So
one of the
we
things
talk-
that we always thought is that anything goes in a black hole goes to another universe. Well, apparently the matter may go, but it leaves this information behind. So, think of it like a gravestone. Well, I'm sorry, Christine, I didn't mean to interrupt you.
No, that's okay. I was just curious, and we were talking a while back about how things kind of bend around each other and how that affects time. How does a black hole actually affect time?
We know that around in the ergosphere twists space and time. And the logical, as much as logic can be applied to this, the segue to that seems to be that it would twist it in the direction that it's spinning. So let's say you got a black hole, you're looking down on it, it's spinning clockwise from the point of view you're looking at.
Mm-hmm.
The space-time at the ergosphere, just outside the event horizon, will be twisted in the same direction. So if you have things that are coming along, all of a sudden they're going to have a radial velocity imparted to them around the hole. As to what that implies for things that are in the ergosphere or near the ergosphere, don't know. Honestly, since nobody's gotten a hold enough. I don't think anybody has a good feel for it. Speculation as to whether that could lead you into things like time travel, teleportation,
Mm-hmm.
faster than light. Faster than light. Okay, let's back off a little bit. When I say faster than light, I mean faster than the observed speed of light in this particular continuum from our point of view.
Right.
And as Einstein pointed out, that's all relative. By the way, just to give in case somebody's going, black holes evaporate, how long do you have to wait? A while. The best estimate of the evaporation of a supermassive black hole is 2 times 10 to the 100th power years. It would be quite a bit longer than the lifetime of the observed universe.
Yeah.
I have a whole lot of fun sitting around waiting on it to happen. But you could measure it. If you had one, nothing was happening, you measured over a fairly short lifetime, say a tenth of that, say 10 billion years, you'd probably see some shrinkage.
That's
if you could measure it.
Now,
Yeah.
Like I'm a black hole calipers and check it.
now do you think they're ever going to be able to locate and be able to go, okay, here is a black hole in our
Yeah.
lifetime?
Oh, absolutely.
Where we're going to be able to go, okay, let the studying begin, turn your telescopes to this point, because right there, this is a black hole. And they'll be able to study.
Absolutely.
That'd be awesome.
Well, to some extent, they've done that already. Okay, you're aware that not all telescopes are visible light.
Right.
We have a lot of what are called radio telescopes out there. Okay, the biggest one I know of is in Arecibo, Chile, I think.
I think I
there may
had
be
that.
a couple of
I
big
think
ones
I had
around
that.
now.
I think I had that in the promo. That's
It's
the,
one of the greatest. It's an absolute great James Bond movie that happened there, which I thought was cool. Good place to film it. All right, Arecibo noticed, and so did a few others, a very interesting, less than 1 second chirp, and they've now defined that. If two black holes hit each other in space, this is a distinctive chirp that is not produced by anything else, and it's the precursor to the gravity waves you're talking about. The gravity waves that they were referring to is what happens when two neutron stars hit each other. Here's what's interesting. The gravity wave and the propagation of that and the amount of time it takes for it to pass by is vastly longer, on the order of several minutes, than what happens when two black holes hit each other. Yeah, here's an interesting point to study. The black holes weigh a hell of a lot more than neutron stars. I mean, those are supermassive, or those are stellar objects. They're hitting each other, and you're getting beep, less than a second. But neutron stars hit each other and last longer. Why? Why would a gravity wave produced by one be so much longer than by the other? So the study's already started. I mean, we already have a handle to some extent on some of the characteristics of it. And look what happened when we had a handle on some of the characteristics of what happens when you make transistors. Next thing you know, 50 years later, we have, computers that we carry in our pocket and make phone calls on and play video games.
It's crazy.
Yeah,
I don't think it's going to be very long. Now, it may be a while before we can actually send a spacecraft out there. But, hey, one of the funny things.
I can't wait till they get deeper into it and actually, are able to begin like putting out information to us, because you go so long on certain things that are theories, and in the scientific community, anyone who's into science realizes there's a lot of arguing and fighting that goes on then. Print dark matter and stuff like, you know what I mean? Lots of theories and more theories, but I can't wait till they actually, have locked in, and they're like, here we have it right here. Here it is. Here's a black hole. We're able to actually study it. It'd be awesome. I can't wait till they're actually able to start putting out actual factual information on it.
As an honest estimate, just from the point of view of the speed of development of science, I think that we are more likely to have practical teleportation before we have practical faster than light travel. Which means it's highly likely that we would be looking at something without attaching a rocket to it and sending it out there by the much more easy, I don't know if you can get back from it, you at least have a one-way travel. Let's send a couple of little robot probes with cameras on them to the vicinity of a black hole. Now, here's the question. If I can teleport you easily from here to Pluto, where the gravity is about the same, more or less, and I teleport you from here to a black hole, since time and space are being twisted around that black hole, does my teleporter still work on that end?
I don't know.
Call me tomorrow. Take 2 aspirin. I'll have an answer for you later.
I wish they would get more into some of this. I'm a fan of, hey, don't risk the people. Let's send. I would love to see them send. If they knew where there was one at, let's see if we can send something there to experience.
Did you know that there has been a
black hole.
proposed mission to Mars during the Obama administration where it was actually proposed and approved for a little while to send a man to Mars?
Yep.
We can, with current technology, send it, but it's a one-way trip. And unless his name is Matt Damon, he ain't coming back.
Yep.
So here's the deal. You know how many people had volunteer for it?
Probably
Every
not.
single member of all of them, everybody in the astronaut corps said, it's worth it. Send me, I'll go.
Wow. I did not
I'll
know that.
spend 3 years in a free orbit and land on Mars and send you back all kinds of information. I'm willing to sacrifice my life to further this. You got to think about it. These people would not be part of the space program unless they thought that way. This is vastly more important to them than or they wouldn't be happy.
Now, just because we're gonna have people of different genres and different levels of understanding of certain things. So let me ask you this: for those who are going to be listening later on, all right, explain why you're saying it's a one-way ticket. Because there's a lot of people that think, well, you got a spaceship, they're going to be able to get back. Of course, they wouldn't send them there if they can't come back.
If you're actually going to get to the surface, you got to do the same thing we did all the way back in 1969, which means you have to have a lander that can maintain its atmosphere where you can breathe in it, and it's got to land on the surface and maintain you alive long enough for you to do some exploration. The reason we're able to get back from 267,000 miles away is because it really doesn't take that much in the way of food, water, or rocket fuel to do that, to take off from the orbit of a tiny little bitty 1/6 gravity celestial body like the moon. If you're going to get back from Mars, all right, let's discuss a couple of terms called perigee and apogee. Perigee is the closest approach of two heavenly bodies to each other. Apogee is the furthest apart they get. Mars' orbit is way, way outside ours. At the furthest away we are from Mars ever is when it's on the far side of the sun from us. That's a long trip. It's our orbit plus the difference between our orbit and Mars to get there. Then you can't aim where it is. You're going to aim where it's going to be when you get there. All right. Same thing. So there's only a certain time frame, a very limited window, where it's close enough to us to make this a reasonable trip. Which means if you're going to come back, you got to come back right now. And even then, you're going to come back a little later because it's moved along in its orbit and so have we, and it's going to be harder to get back. So the most reasonable thing is to go there, spend some time, and then come back. How do you get back? You've got to have the same amount of fuel, more or less, because the gravitational pull doesn't mean anything at this distance, to get from Mars to Earth as you do from Earth to Mars. If you're going to land on there, Mars has about 1/3 the gravity Earth's got. It's going to be a little easier to take off and a little easier to leave, but it's still going to be a significant portion. How do you, A, load enough fuel onto a rocket ship to be able to get it back from there? And how do you, B, load enough food and water for people to survive for the amount of time they're going to have to wait until it's close enough for us to do this once again?
Now, the
I
time
think
frames,
Asimov,
the time frames that you're talking about, what are you looking at for like time frames?
to get there, to get back,
Well, I mean
I'm
the
not
waiting.
sure if they've modified this very much.
I mean the waiting. In other words, the arrival
About
takes
a year and a
place.
half.
Okay, so you have to wait a year and a
I
half. So you
think
have to
last I read was about a year and a half.
So you have to be there for it. So you're going to have to also, no matter what, have a redundancy built in. So if it's a year and a half, you're going to have enough for 3 years, because if you miss, you don't want to go, that's it, you're dead. You want to at least have a second shot at doing it. So what about like pulse engines? Wouldn't that reduce the amount of fuel that you would have to carry? Or could you use a different type of
pulse
fuel?
engine is an atmospheric kind of phenomenon. Currently, the best one next time in the future, that's the best time for us to go, is about 2025. But to back up a little bit, no, a pulse engine reacts by squirting, at least the one I know about, squirting liquid hydrogen onto the bottom of a superheated airplane. And that's not going to be effective or even similar to what you would want to do for a rocket engine.
Okay.
The shortest, the reasonable one, if we could go to Mars, we could spend 10 days there and come back and still hit a reasonable window. But then there's a long one, which means it's about 2 years you stay there, not a year and a half. You're looking for opposition when Mars and Earth are as close to each other as they're going to be. And you're looking for what's called a Hohmann transfer orbit, which is that's the lowest energy orbit. It's the widest trajectory. It kind of whips you around. It uses a gravity well to get you there. Okay, if that helps any.
I just always wonder why is nuclear not possible? I mean, we've got a good harnessing on nuclear right now. We've got ships that can go underwater for a year and a half, 2 years because they stay there as long as they want to. We've got a pretty good harness on nuclear power. I've always wondered, is it because it would be steam or whatever else you have to say again?
Reasons. The first one, as you allude to, is political. There's a treaty at the moment which says we will not put nuclear reactors in orbit. And that's signed by all of the spacefaring nations, if you will. I won't say they're not cheating on it, but so far they've said they haven't. The point is, nobody wants an atomic pile to fall back down out of orbit with an accident and hit somewhere. Not that it would detonate, but it sure would make a really, really nasty ecological disaster, have that much radioactive crap bouncing over the countryside. And if it starts to fall apart in midair and burns up like a meteor, now you get even more radioactive dust. Effectively, you've done a pretty good population control part of the planet that goes over. But the second one, realistically, is yes, you can achieve extremely high temperatures. So that black hole that you were talking about, by using it as a space drive, that's excellent because it's very small. Not that it doesn't weigh much; it's pretty heavy, but it would be very difficult to do an atomic pile into orbit. You're going to have to move the whole thing up there. You've got to transfer fissionable material, cadmium, and all of the things in the world that keep it running up into orbit, and then use it, and it's got to have something to react with. Well, whatever it reacts with is throwing away. So eventually you're going to run out of whatever it is. I mean, submarines typically at the moment use a heat exchanger in their reactors, and a few years ago they're using liquid sodium through a dual coil reactor. They're using liquid sodium directly out of the heart of how hot that atomic pile is to heat up steam, to superheated steam, to be able to run the propulsion of the submarine for Americans at least. I think the Russians did the same thing.
Yeah.
It's kind of hard to do that in space. I mean, we're not running a propeller through the water.
Well, no,
in order to get a rocket to move, you got to throw things out the back end. So you're talking several tons of nuclear pile that you're adding to the weight of the spaceship. And after all, you're talking about a spaceship that's not really built a whole lot more sturdy than an airplane. As John Glenn pointed out more than once, this is a really pretty flimsy thing to be putting your butt on top of and firing that candle up into the air. It's engineering-wise, it's just not feasible at the moment. It won't ever be, but it's not right now. I mean, if you wanted to use it for a power source for a space station, hey, that's probably a pretty good idea. But for a rocket that's actually got, the thing is, all rockets have to take advantage of the fact that they're losing weight as they use fuel. And that makes them easier to accelerate as they go. But you got to have enough fuel on board to be able to burn it long enough to get it to go where you want it to go. And then hopefully you have to have enough fuel on board to get it to go into the right orbit to insert it in when you get there, so you don't go flying on past or hit the surface. Either one of which is kind of tough to survive. So I guess the point is, actually there was a window in 2018 to get to Mars, but obviously we didn't make that one. So 2025 is the next reasonable one. And I tend to think they're going to do both. They're going to land somebody there for 2 years, and leave them there. And they're also going to have people, one crew wait there about 10 days and come on back.
That would be something else.
Because realistically, it wouldn't be that hard to grow plants on Mars. We know what the soil's like. That's part of the reason for the Spirit and Opportunity modules running around out there. They got a pretty good idea what kind of soil there is. We also know there's water. We know where the water is. Just not that tough. The only thing that's hard to get is air. But we have oxygen. All you got to do is run a compressor. What do you use to power your compressor? Yeah, nuclear power would be nice to have, but solar cells work pretty good. However, you're talking about a planet that is a lot further away from the sun than we are. So you need a lot more solar cells to get stuff to run. So if you're going to stay there 2 years, you got to do some serious planning. The best plan that I've ever heard of so far, boy, we're a long way from black holes right here, is to launch 2 or 3 unmanned missions and have them land robotically, because we don't really care necessarily if they make it, and let them land. And then have us go up there and take advantage of what was landed with the unmanned missions. Got a whole bunch of supplies.
Yeah.
At least enough to let you survive 2 years.
That makes a lot of sense.
Yeah. It's a lot more money, though. You got to sell Congress on it. You want to launch how many rockets to Mars? My constituents are not going to like that. I don't think they'll vote for me again if you tell them you want to spend your money on that. By God, we need to spend it on eradicating the boll weevil.
Good luck with that.
Back to you, Christine.
Well, John, did that answer your question?
Yeah, we went down a science rabbit hole. I'm sorry.
Now who had the squirrel moment? I just want to ask. Now who had the squirrel moment?
Yes, that was me.
Okay, well, anyways, going back to the black hole, my other question too is, I know we kind of talked about this a little bit before when you were talking about the black holes. And so is there any studies or theories out there to say typically how long a black hole can or will last?
Oh, yeah. Yeah. The best one is Stephen Hawking again, and the Hawking radiation. It depends. Now, this is begging the question. This is how long a black hole lasts with no input.
Mm-hmm.
How long? If you had a supermassive black hole in the middle of our galaxy, which we do, and it's sitting there without eating much stuff, which it is, how long is it before something else happens to get close to it and feeds it a little more? That all depends, and it's strictly a matter of chance. It's like playing pool. Is it going to go near the pocket? Is it going to end up in the middle of the table? If you look at there are at the moment in the center of our galaxy, we've charted 13 suns.
Mm-hmm.
They're moving real fast, spinning like a cyclone around the middle of the galaxy.
Mm-hmm.
They have a fairly typically stable orbit. In other words, none of them are actually being... All right, suns get pulled apart near black holes by tidal forces. And there's some really good diagrams of how it looks when you start sucking off the photosphere of the sun into a black hole.
Mm-hmm.
None of these that we can see is that happening, but would we see it? Yeah. Don't know.
Yeah.
We don't really have that good a telescope yet.
Mm-hmm.
So I don't know. Honestly, the black body radiation thing or Hawking radiation gives, some upper limits.
Yeah.
I don't think you're going to have one. I don't know what would eradicate one. I mean, it's kind of like, as John says, the massive Hoover. The more you feed it, the bigger it's going to get. You stop feeding it, it's just going to sit there and wait till you feed it again.
Yeah, not like your dog or cat that wants to get fed all the time and will chronically complain until you do something about it.
Right. So 10 to 100th years. 10 to the 100th power years.
Wow, that's just crazy. Some of the stuff when I don't know about you, John, but some of the stuff when we started looking into it, you really do kind of have to have an open mind.
Yeah,
And
oh
some of
yes.
it you just cannot, I think, for most average people, wrap their heads around it.
Well, there's also the whole. There's also you got all these brilliant minds. All right. I I'll say this as gently and as politely as I can, but there's a lot of things in science that you have a lot of these brilliant minds that are
Mm-hmm.
going and going and going on it, and none of it's actually been not all of it, but some
Mm-hmm.
things that they're on haven't been proven.
Yeah.
Theoretical physicists. Okay,
Right.
they have theories. You know what I mean? Dark matter, these types of
Yeah.
things, string theory, all these types of things. And they're not proven yet. So you have brilliant minds that are working on trying to prove something exists or explain how something is. So
Right.
that kind of messes with your brain. It's always sitting on the side
Mm-hmm.
of my head, going, "So is this one of those
Yeah.
deals,
Yeah.
or how do I know where to go in this? How do I know what
Yeah.
what path am I studying to learn?" So I just try to study it all, so that way I go
Mm-hmm.
into it with an open mind. I realize
Yeah.
any of it's possible, but also at any minute somebody could go, "Oh, now I get it.
Yeah.
Okay, now I get it," and then headed off in a different direction.
Mm-hmm.
And those days,
Absolutely.
and for those folks that are listening, that never happens. It does happen, because as soon as Einstein had the theory of relativity, that was a moment it happened right there. Everything changed at that moment right there. So that's one of those moments. If you ever wondered, name a moment where that actually happened, right there. There's one. Every time we discover something new,
Yeah.
every time something is discovered or something is proven, that's one of those moments. Those aha moments. That's what they're all working towards. They're trying to understand. So you got to go into it with an open mind. But it is wild. It is wild how many theories are out there.
Yeah. That was the other thing that really amazed me is all the different theories. And that kind of led me to another question. It's like, how does one get to a point where they can say this is a theory? I mean, do people just like throw it out there and then the rest of us go, okay, that sounds good. Let's make it a theory. I mean, how does it like even get to that point? I mean, because when you think about it, you're talking and thinking about something really outside the box of what we normally would, consider thinking about.
And it's
So,
and
like, how does that even
I,
get started?
I understand where you're coming from, because once the person has this idea, it's
Great.
like, I don't have anything to back it up, but I really, really, really believe it, and I've done a lot of
Yeah.
mathematical problems that make me believe I'm right.
Mm-hmm. It just blows my mind.
Yeah,
It really does.
but I guess Dr. Mark, you have to have what the scientific communities go, "Hey, he could be right," or is it literally
Well,
just I threw it against the
I'll
wall
tell you
and
what I was
stopped?
taught.
Okay.
A hypothesis is a limited explanation of a phenomenon.
All
A
right.
scientific theory, or a theorem, depending on what you listen to,
Mm-hmm.
is an in-depth explanation of the observed phenomenon. A law is a statement about the observed phenomenon or a unifying concept that is generally accepted to be true by the majority of the scientific community.
Okay. So
Okay.
At
basically,
least that was what I was taught in science class.
right. So
Okay.
basically, a theory is just that, Christine. It's a theory. I believe this
Yeah.
could be
But it's an
what
in-depth one.
explains it. Right. I believe this would be what that this explains it. So yeah, that's
Yeah.
So, is there, Dr. Murphy, do you know, like, okay, so people that project these theories out there about black holes, do you know, like, the flip side of the coin, is there people out there that challenge those theories and say, well,
Oh,
no,
yeah.
it's not that, it should be this?
the fight.
Absolutely.
And do you have an example of maybe one of those?
Yeah, I can give you several, as a matter of fact. Okay. I'm not really sure to put this. All right.
I just
If
don't
you
know.
have seen a couple of prima donna divas fighting each other over who gets more stage space, you've never even approached the level of two Nobel Prize winners arguing about over who gets more column space in a scientific paper. They will insult each other's families, ancestries, parents, dogs, children, and anything else, and they'll get shrill and they'll get in a slap fight. I'm serious. It's nasty. There is no maturity, and there's nothing noble about some of the Nobel Prize winners you've seen out there. When in the 1920s, when people like Oppenheimer and Niels Bohr and Schrodinger and Heisenberg started thinking that quantum theory was really something they needed to explore, Albert Einstein absolutely denied it. And two of the things that Albert Einstein said at the time, and you got to admit, and it's true, he was a great man. He was a great intellect. He had insights nobody had ever had up to that point, but he called it spooky action at a distance. In other words, he was calling it superstition. The other thing he told them famously is God does not play dice with the universe. And Heisenberg responded that God not only plays dice with the universe, but he cheats. In other words, they were saying that actually things sometimes are what you wish them to be, and sometimes they're inexplicable, and Einstein stood his ground and refused to believe it. And he refused to believe in quantum mechanics until at least the 1950s, long after. And he finally had to backtrack a little bit and goes, well, maybe there's something to this after all. And it had been the accepted background. And that's talking about some of the better ones. Einstein and these guys were all world famous, justifiably so, scientists with great mathematical minds.
Right.
Right now we're talking about people like Hawking and Neil deGrasse Tyson and Michio Kaku, who are fighting each other over who gets more time on the History Channel and who has to compete with ancient aliens to be able to tell you what the actual truth is about physics, astronomy, and biology.
And who's the girl? Who's the girl that's always in it too? The younger one.
Oh, which one? Yeah, there's one geologist on there going, whoa, okay.
She's
I thought they were all supposed to be ugly.
I think she's a physical. A theoretical physicist, I believe she is. She's
Could
young.
be. There's a bunch of nice ones on there.
She's younger.
There's one brunette who's about 6 foot tall on there, and she's in Cambridge, I want to say. I know she's a Brit.
The one I'm thinking of is a
gorgeous.
little. The one I'm thinking of, she's just a little bit. I mean, this is a little girl. She's kind of a strawberry blonde, very soft spoken, but apparently she gets in a lot of pissing matches with them as well. Over those same things, that you were talking about there. Because apparently, when the History Channel came on, it opened up another can of worms. Apparently, it was another medium that got people on TV, and before you know it, people started watching the History Channel because it was able to explain things to them. And to be that person who's known as the explainer, that's what they want. The Japanese fellow there. I forget his name. He's on.
Yeah, Michio Kaku.
Yes,
I like Michio because he's a professional figure skater. This is not something you expect among a theoretical physicist who has a math PhD as well.
What?
He really is. He's good. He's
and it's like the same thing. It created a whole bunch of diva monsters because there's a guy. I don't know if he's from Israel or where he's from, who does digs in Egypt and all that, and apparently he's a freaking diva now too. Also because of the History Channel, and he's a screamer, yeller. Stay away from me. He's like, I am the god of the digs. Apparently, it created a whole bunch of friggin' scientific divas at Discovery Channel.
The one I think you might be thinking of is Lisa Randall.
That sounds familiar.
She's in NYU. Or I think, and Harvard and all this kind of stuff. And of course, she was 62, so she's not that young yet. It may not be the right one. My point is that these people are more jealous of their prerogatives and more hateful toward each other. So even if they might believe you, they might say, "Hey, Christine, that's the most brilliant thing since sliced bread. I really like it." When you get out there, they're going to stab you in the back because they didn't come up with it. Okay.
I'm sorry, but don't send me hate mail, but that just sounds really childish.
It was true. It really is.
Well, have you guys heard Christine's theory of soda fountains. Oh my God! Tell us, Christine. I just happened.
Soda fountains?
What?
I like it.
It was just something to throw out there.
Oh, okay.
I couldn't think of another theory, so I just threw out the theory of soda.
For a second there, I'm like,
I worked in a company. I was an explosives engineer for a company for a while. And in our lab outside Montreal, we had a building that was completely full of PhDs, like 210 of them, I think. And a man I worked for and I were the only people in the building who did not have doctorates. We actually had 3 or 4 working for us. And we would be, one of them kind of took me under his wing. He's a very, very wise British guy. What he was doing in Canada, he'd call himself an expat there. And he refused to learn French, which is odd in Quebec. But Phil told me an interesting thing. He said, you need to learn how to handle yourself in a boardroom. And I said, I'm never going to be in the boardroom. I'm not going to be on the board. And he goes, no, it's the same thing. You have a scientific conference here, and we had this guy get up here and give all these brilliant things. And it's really good work. And I have to admit it's good. And it's some really groundbreaking stuff, and it's impressive. And he said, but you have to remember the vice presidents and senior vice presidents are not really technical people. They were put there because they know somebody or because they were the right person at the right time, and they usually don't understand what the heck the rest of us are doing out here in the middle of the field. I said, true. He goes, so here's what you do. You undermine them subtly. You look at them and say, I understand you did. That's really good work, but why didn't you think about studying this part? And he can't turn around to you in the middle of the meeting and goes, because only a bloody fool would waste his time going down that damn rabbit hole. It has nothing profitable there. There are no carrots. You can't say that in the middle of the thing. Instead, you have to look thoughtful and consider what your colleagues are asking you because they have a valid thing. And immediately that vice president will turn around, yeah, why didn't you do that? And you're looking at him wanting to tell him, because you're a friggin' blippin' idiot. And only a blippin' idiot would believe this fool when he's asking these. Everybody in this room knows it's stupid. You can't do that. And he said, so it's real subtle. So now all of a sudden this guy finds out that his funding is cut off because he can't explain why he decided not to pursue a rabbit hole when he was hunting foxes. You know?
There you go.
And it works real well. He said, all you have to, and these people are masters. I mean, that was a very minor example among professional engineers. I'm talking people who have honed that to a skill. They know exactly how, and the guys in the History Channel don't know. They go, well, I don't understand. Why didn't you follow that line of reasoning? Okay, I'm supposed to explain to you from my 30-year PhD and my 25 years experience on top of this why I made a simple logical decision? No, because you don't have the wit to understand it.
Mm-hmm.
Yeah, now they have a TV show that is geared toward 8th grade educations, and it has a whole bunch of people that, as you say, are divas, and they're fighting with each other for camera space. And now they have to sit there and explain themselves to people who don't have the wit to understand them. Yeah, I was always told that you can always tell the really good ones because they never show up on camera. That's a good point. So the ones on camera are the ones we need to ignore. Back in the day, Carl Sagan, everybody goes, oh, he was a great scientist. Well, I have to tell you, in the scientific community, there was nobody as vilified as Carl Sagan. Now, I've had people tell me that it was because, well, he was a brilliant man and they were jealous. Well, no. All of the real engineers and astrophysicists and stuff I've ever worked with said, no, it's because he never met a camera he didn't like. He was always putting himself up in front of the camera. And everybody was convinced, oh, wow, he must be the only one that knows this stuff, so he must be really, really smart. No. What it was is really, really ego-driven. That's all there was to it. So, yeah. So in answer to your question, no, it's ugly out there. It really is.
I had an idea, but I had no idea at the same time.
Okay, take people. Do you know how to get a PhD these days from a major university?
I wouldn't have the first clue as to how about doing that.
Well, you got to
university.
get in grad school first, but there are so few people applying for scientific ones. But here's what you do. You find out who's on your thesis committee. Mm-hmm. All 6 or 7 of them, all of them grave, silver-haired people with, PhDs and everything, and they've been doing this a long time, and they're tenured professors.
Mhm.
And it's easier now with Google, but in the old day, you actually had to go to the library and put forth some effort. And what you do is you pull up 3 to 4 papers of each one of them. And
Mhm.
in your thesis, you quote them extensively and justify exactly what they found in their research in yours. And whoever the head advisor, the head of the committee is, you
Mhm.
quote 5 of his papers and prove how brilliant they must have been. It has absolutely nothing to do with you doing any real work. All you have to do is flatter the hell out of them. They'll give you a doctorate.
So basically, you're kissing butt.
Absolutely. Your nose is going to be so brown you never need to worry about getting a tan again. It'll be the brownest anybody's ever seen. And that's the way it's done. It absolutely is true, I think. I guarantee it. Yeah.
That's the craziest
So
thing I've heard.
it's sad but true.
Mm-hmm.
So this is what you end up with. You end up with people with a romper room mentality and a Nobel Prize and a doctorate. And the corollary to that is the fields of study for PhDs are getting to where you know more and more about less and less until by the time you graduate, you know everything about nothing at all.
It's a very good point.
And it really is. And by the time you get that specialized,
Oh, man.
you have a field that has exactly one person in that whole field. You.
Yeah.
You're the only one.
I was gonna say you'd have to be the only one.
Really. It's the way it works. Yeah, no wonder this country's falling apart.
Question for you: What? Before we all depart here, what scientific principle in space right now would you recommend, Dr. Mark, to keep your eye on? This is something that's going to be really interesting. Something that you think is going to be a big thing happening here in our future, a future that we can all see. What big discovery, what big thing do you think is on the horizon?
It depends on which way you want to look at it. If you're not talking a technical but more of a public and political one, private space flight. Privatization of space flight by people like Richard Branson and Elon Musk is the only way we're ever going to get off this planet.
Yeah.
If you're talking about technical, we've evolved some really interesting materials up there, and I think they're going to stand us in extremely good stead. The one thing that we predicted for years and years, and I'm amazed we haven't done it yet, are 2 things. First of all, putting a space station up there. And second, have you ever heard of a skyhook?
Yeah.
Okay. I don't know why we haven't done one. We are coming up on having the right materials to be able to do it. Synthetic spider silk, running from a geostationary satellite down to the ground and running elevators up and down it all day long. Ultimately simple. No space flight intended.
That was
And-
something that I've looked at the different principles of that so many times, and when you realize that actually we have the ability to do that, it makes you wonder why has that not been. I mean, just the safety aspects, and plus like the cost.
Well,
Holy crap, the cost!
Think about the cost.
Yeah.
Well, the cost is huge, and you're not going to convince people that if it falls out of the sky, oh, what if it breaks? Well, it's going to fall on us. Well, yeah, it could be. It's a long damn cable. It's going to make a big pile wherever it lands, and whoever's under it's not going to be happy at all.
Right.
I will tell you the one I really look forward to. I wish it would happen. This is wishful thinking, and it's exactly what we were talking about last night. I want a moon base. A moon base would be a less of an investment to start with than a skyhook. But the skyhook would be more practical because if you think about it, how would be an easy way to get from the Earth to the moon? You sit outside the gravity well up there in a geostationary orbit at 22,000 miles and use a magnetic sling and toss people to the moon. 267,000 miles away, it's an easy toss. They don't even have to have anything but a rocket to slow them down when they get there. Or better yet, let's don't even have one. Let's put a space station orbit around the moon. You go from one space station to the other, and you know how you conserve the momentum. It's just like driving a Tesla.
Yep.
This sling, I have a what's called a regeneration. Basically, it's an electromagnet. I catch a rocket coming from the moon. It spins round and round while I slow it down by charging up my battery. Then I take one from the Earth and I use that battery and fling it to the moon. The moon catches it, spins up, and charges their battery by slowing it down. Now, going from the moon down, probably don't even need a skyhook. I use a rocket. It's only 1/6 gravity. That's easy. Use liquid hydrogen. You got water on the moon, 600 million tons at least. Crack some of it down, make hydrogen and oxygen out, breathe the oxygen, burn the hydrogen in your spaceship. Good to go.
I wonder why
Problem
they haven't
solved.
done a station on the moon. That doesn't make sense to
A
me. Why
million
not?
reasons. Remember what we were talking about the fights between,
Oh yeah.
okay, who owns the moon? If you went up there and planted a flag on it, who owns it? It's not like Columbus and Queen Isabella.
Well, I
If
don't
you
know.
stick a flag in it, there's an interstellar, I guess it is interstellar. There's the first non-terrestrial treaty, which says the moon is owned by all the nations on the Earth equally. That means Guinea-Bissau, with a total population of God knows what and a total budget of $250 per year, owns as much of the moon, theoretically, as we do. You know,
But we have
Togo in the
we have the International Space Station. Why can't we operate there with that same principle? I mean, we're working with
the International Space Station is very, very small and very, very low technology-wise. I mean, you remember the movie Armageddon where that idiot Russian, who's actually
Yep.
really a Swede,
Yep.
blew it up? Well,
Yep.
that's a really level of technology we got up there. You got to keep modernizing this thing. It is decades, not years
Well,
out of date.
that's what I'm basically saying is that thing is a has been, and plus it's actually it's a target. I mean, it's the skin is so thin, and we have so many projectiles. A lot of people don't even realize that, but there's a constant barrage of projectiles heading at that thing at an ungodly speed.
right?
And if it gets
The
hit,
International Space Station was built on 1970s technology to function in the 1980s, and now is working until 2018. Yeah, it's just not really. It's a catch-all. They wanted a place to do experiments to prove the viability of a space station in space. Well, how good are zero gravity experiments, and what can they teach us? It's now time to move on to the next one, but nobody has the political will or the monetary capital to seem to want to do it.
well, that's to me would be that's the next thing. To me, it would be let's pull a whole global effort together and let's go now. Instead of building the space station, we're still putting modules out there. Instead of putting all that money there, that money should be going to a actual physical station on the moon.
Right.
To me, that seems like that would be that's the best possible. I mean, you put a small colony on the moon. You're still doing all those experiments, but you're learning more. You're able to start actually developing something on the moon. Can we grow crops there? Are we able
The
to
International Space Station, you can stand down here and point at it. You can see it in the sky with your naked eye at the right time. It is owned by 15 countries and 5 space agencies, and there are contracts surrounding it that make the ownership of a bank and an insurance company look simple. Nobody wants to get into that again. Everybody wants to land on the moon and run their own thing their own way. And unfortunately, we've now made that totally impossible with the history of cooperation in space with the ISS and everything else. We'd have to actually have a joint landing crew, if you will, on the moon, and you'd have to have everybody on it be able to speak English, Mandarin, and Russian simultaneously in order for it to get there. And maybe Indian, for all I know.
Oh boy.
Yeah,
Well,
I mean,
let's
I hate
get
to
on
sound
it,
like
people.
a Pollyanna, but it's really true. Yeah.
Let's get
The
on
thing
it,
is,
people.
if Elon is willing to take his money and use making fast electric cars into making affordable electric cars, then I'm assuming he's willing to take some of the rest of his money and build a space station or a moon base. After all, what would stop Elon from building a base on the moon?
Well, see, that's what I'm talking about. I mean, there's got to be a way for it to be done, and I mean, they can't stop him, can they?
I don't know. I'm totally unfamiliar with the laws regulating what we could do on the moon. I don't think he could. I think that, okay, have you heard?
You see him go up for a personal flight. He's got 10 people there. Before you know it, there's like 12 pup tents. There's 12
I
pup
like
tents
the idea
up
of
on
the
the
first
moon.
thing he launched into. What was the first thing he launched into space? A Tesla. And everybody goes, "This is really stupid. It's going to come apart." No, it's an electric car. He doesn't need to worry about finding a gas station, just a solar cell.
That's right.
Duh, he's a brilliant man. He can drive it on the moon. It's
There
the
you go.
only car that we've ever made that you can drive on the moon. It can be driven on Earth too. He's a brilliant guy. I like it. I'm not sure it'll ever land, but what the hell? I wonder if he can or not, or if maybe he should ignore it. If he ignores it, then I'm assuming you're probably going to find some Russian bureaucrats who are going to ignore it, and maybe one or two Chinese entrepreneurs who have billions of dollars to do the same thing. I don't see a problem with any of this. I think it's got to happen. We got to get off this mud ball.
I
We
can't
got
wait
all
till
our eggs in one basket.
I can't wait till the day someone goes, get a hold of Hawaii quick. Get a hold of Chile. Tell them to train train the telescopes up there, and there's like 12 Quonset huts there. And a bunch of people going, ha, 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 we didn't bother with you assholes. We just went ahead and did it. Here we go.
Right.
I think it'll be awesome. I think they need to get up there. I mean, get established there. What can the moon do for us? You know what I mean? What can it do for us? I'm not saying destroy it, suck it dry, deplete it of everything. I'm not saying that. I mean, what can it do for us? What can it teach us? What can we learn from it? Is it
Right.
a place we can go? What if there ever has to be a great escape? You don't know anything about the moon. When you have to absolutely get to it, it'd be a really stupid time to start discovering. I mean, we really haven't done anything. I know that's a long shot.
The ESA, the European Space Agency, says it's going to build an international village on the moon between 2020 and 2030. And NASA says it's going to build a moon base. And the China National Space Agency says the same thing.
Well,
so
it's time. Can't wait. I hope they do.
A lot of
Yeah,
people, a lot of planning, and everybody's got to be on the same page. It's a lot.
I think that's why they call it diplomacy. So in case you're not on the same page, you can still work it out.
Right. I'm just saying that that's a lot to get to that point in order to progress forward.
Back in the 50s, Robert Heinlein wrote a short story called Requiem, and was about how the only way to get to the moon was through privatization of spaceflight. And a very rich man who owned a lot of industries down here was determined from the day he was a kid, the reason he made all his billions of dollars, to get to the moon.
Mm-hmm.
And he eventually financed the first moon flight, and that's how they got up there and came back and so on. And he sold it. I mean, he was a shameless advertiser, and he came up with a dozen different ways to get the public on his side to do it. I'm not sure he was completely wrong. I mean, I think it took us longer than it should have to get there because we didn't privatize it. Then again, nobody's really willing to take it up. And back in the day, NASA still meant NASA to everybody.
Yeah. Yeah, that's true.
Yeah, I don't know. But back to your question originally, John, what kind of technology would I see as the next big thing? The one thing that I will say as a halfway answer to that is inevitably, whenever anybody with a scientific education tries to make a prediction like that, they always shoot it short.
Mm-hmm.
Whatever happens, really happens, goes, whoa, I didn't see that coming.
Yeah.
It's way beyond anything we would ever dare to say. And I think it's probably what's going to happen here. It's going to surprise the heck out of me and go, well, duh. Hindsight says I should have seen that coming.
Well, it's been a long time since we've had one of the life-changing discoveries. You know what I mean? You have this penicillin, you have antibiotics, the telegraph, light bulb. I mean, electricity, magnifying lenses, transistors, domestication of the horse. Those great things that have happened throughout time that changed everything for everyone, for the good. We haven't had one of those in so long.
Yep. Why?
Some people say the computer, and I say no, that's not it. Transistors were it. So
Why haven't we seen one in a long time?
I don't know. I don't know why we haven't.
You know how they always say that both cultural and political and societal changes are like a pendulum. They swing a long way in one direction and they come back and swing a long way in the other direction, and it's always periodic. I think the one we're in right now is where too many of the people hold too much of the power for decision makings over things like that, are too comfortable with where they are. And there's not enough people with enough push to make them uncomfortable or to say, hey, I want to do things my way. And because they're so comfortable, there's nothing more comfortable than a man in power, especially a man with gray hair or white hair in power, than the status quo. The status quo says I get to keep what I got, and my kids get to, and I get to watch my grandkids play, and you can't have any, and I like it that way, and I'm going to keep it that way. Change is very rarely comfortable, and sometimes it's fatal to a lot of people.
Well,
I mean, Russian Revolution, everything like that, all the things that went on when we've had upheavals that actually led to a great deal of progress. Look at you're talking about all the changes we had. At about the time those changes came along, what else was going on? When did we hit the industrial society in the United States? Right after Napoleon, after the American Revolution. When did we start hitting transistors and plastics? Right after World War II.
Yep, right after, yep.
The point is, all these upheavals killed a whole bunch of people, and they made a whole bunch of other people a whole lot less than comfortable. And discomfort, I mean, the trite thing is necessity is the mother of invention. Well, actually, discomfort is the mother of invention.
Well,
people want to be comfortable.
That's true. That is very true. It's just that to me, there's so much intelligence out there. There's so many things that we don't know. No matter how smart we think we are, we don't know. There's so many massive things that are going to be so great that are going to happen. I'm just sitting around waiting, going, I want to see some more of this happen in my lifetime, and I want to see some of those great things happen. The things that actually.
Well, as a parable.
Go ahead.
Let me give you another science fiction story that's a good parable of that. One character in one author's line invented the perfect battery. The perfect battery. You could store almost any kind of energy into it, especially electricity, at almost any level, and it would stay forever and would not leak out. It's very lightweight.
Okay.
The cultural ramifications of that were unbelievable. And the thing is, it was so simple to make that you didn't have to buy any materials from anybody. You could go to your local hardware store and build your own. The very first thing he did was go home and tell his wife, and the very first thing she told him was, shut the hell up. And she said, you need to hide this as well as you can until you can figure out a way to release it to everybody in the world simultaneously. There is no way in the world to keep a secret this big, but there are a lot of people in the world that will kill you to make it secret. The only way you're ever going to stay alive is if you release this where they cannot squelch it.
Now that you said that,
And
I
that's what he did.
I don't know if you've ever seen this or not. I saw it one time. I've never been able to find it again. And it was literally on the Discovery Channel. And when you contact them, they don't answer anything about it. I was up late one night, couldn't sleep, and all of a sudden this show comes on, and it's about a carbon digester. This guy has built a carbon digester that will produce anything. And literally, they're bringing truckloads of trash to this guy. Like, don't go to the landfills anymore. Just bring me your garbage trucks full and dump them here. Everything goes in. It's superheated. And then he's converting this through this digester into number 2 diesel. And they wouldn't allow him to, they would not allow him to sell it. But he had an unlimited supply of it. And he was like, this needs to get out to everybody. And I saw that show, and I was like, wow, I was thinking about it for like a week. I was so amazed. I was like, I got to see that again. I want to watch it again. So I just kept trying to see where I could find it. I've never been able to find it ever again since. But it was on, and it was a carbon digester. And no matter, and he couldn't produce pure, he couldn't produce crude oil or any of that. It produced a number 2 grade diesel.
Right.
But it was from anything. Everything's carbon based, so that was it. It was a carbon digester, and he was able through this heating process that he had, and they showed rows of trash trucks just pulling up, dumping. That's it. And he was like, "That's what I have to have." And some stuff was burnt to produce the heat, and the rest of it was just going in to be the fuel. I was blown away. I was like, "Why are we doing this?" But I've never seen it or heard a word about it since.
Well, I'll give you a couple of possibilities that are diametrically opposed to each other. Number one, it was a hoax. Somebody set it up as a really, really good segment on the History Channel. The History Channel found out they were hoaxed either by the producer or by somebody who put this video together and it doesn't exist, and they're embarrassed and they won't ever
Oh no,
admit
they were in the plant.
number two,
they were in the plant.
No, I understand, but I can set you up a plant that you can't tell the difference between that and another,
Okay.
and have diesel come out the other end, biodiesel. It's not a problem. Or the second, more likely one, he's dead. And the History Channel was told you'll follow him if you ever show this again. And television producers are not known for their major big brass ones. They said, "Yes, sir, don't hurt me." I think that's probably more likely.
Yeah, because
I mean, it's like the old 200 mile a gallon carburetor they were talking about, decades ago. Same sort of thing. Did it exist? Didn't it? Who knows?
Yeah, because
Did the big old companies kill the guy?
The guy was young. He was like in his late 30s, and I mean, he's out. He was also proud, and he was showing the processes and how everything's done. They got multiple camera angles, and I'm like blown away. I'm going, "Oh my god!" And I was like, for me, this was like, here's one of those moments I've always wanted to see happen that changes the world. That's probably why I was so interested, because I'm always looking for one of those. When's one of those going to happen that I can watch? This was one of them, and I was watching it, and I was blown away. And since that date, never ever heard another word about it. Can't find anything on it even. And it doesn't seem like it'd be that hard to find information about a show that was on television. But boy,
if you remember exactly what day it was on, you could go back and look at their list of old programs.
Yeah, I don't remember the exact date. It's been a few years now. But I mean, I just thought it was amazing. I can't find a thing about this guy. And he was very specific about I'm not allowed to sell it. I cannot sell it. There's so much testing and so much this and so much that and regulation and this and that. And there's so many hoops. He goes, but I can give it away. And he was giving away to all the farmers around him, and everything was being converted to diesel around them, and he was just giving the stuff away. And it seemed so amazing because it was helping landfills. There were so many positives to this. You're like, oh my God, what's the negative? What is the negative?
Really? The negative is if you're Shell or Exxon.
Mm-hmm.
No, this is
That's
true.
what they're saying. Somebody's not making money off of it. Not going to happen.
But you would think that rather than not making, to me, in my brain anyways, if I was the evil henchman, it would be like this. I actually would want that thing because that thing requires less financial output from me. It can be fed for free by all the landfills. I could actually pretend to be helping the world while I'm getting all my supplies for free. And I can actually sell it for whatever price I want. It's totally refined. I don't have to pay refineries. It's all done right here. That's what I would want to do if I was Exxon or Mobil. I'd want to take that. I want to get my hands on that. Pay the guy a big chunk of cash. Yep. You go away. Now that's my technology. Because trust me, if I don't have to drill, I don't have to go through all the crap of building those giant oil rigs. I don't got to do any of that crap. All I got to do is build these carbon digesters. Oh, hell, I'm on it. That's less output for me, all pure cash.
I went through a course of risk engineering quite a few years ago in a suburb of Chicago to the northwest out there, and it's a pretty good-sized company, and we toured a lot of different engineering places that were doing interesting things, and one of the ones we went to was the biggest landfill outside Chicago, and it was multiple hundreds of acres. And the trash trucks would pull up on top of these mountains. Literally, these things were 400 and 500 feet high. That was the biggest pile of trash I ever saw. And they would just dump this stuff. And some of them they had finished, and they had covered them over in black plastic. And that black plastic was sealed. And at the top of every single one of them, they had a little pipe that was going in, and it was sealed to the plastic. And I went, And we went in there, and they had gas, as in propane and methane, mostly methane, coming into this little metered station. They were using the digestive properties on that trash, and it was just a landfill. It was They didn't even cycle it out. They didn't even separate it, and they were making methane and running it. And they had a high enough pressure. They had to watch their pressure. And I went, damn. So there are other people, even municipalities, doing it.
Well, yeah, because the big thing he was
I
talking.
was really intrigued because that was a lot they were producing.
The big thing that he was talking about is he was like, and imagine this. He was talking about just tires. He goes, tires go in this way, diesel comes out that way. It's that simple, people. And I was blown away. I'm like, so he was actually, he had so many ways of turning this stuff into fuel. I was like blown away by this, but I haven't seen anything about it since. So you said in Chicago, huh? Well, I'm gonna head down I'm gonna head down this rabbit hole. Christine's gonna be looking at me going,
Okay.
Black holes, John. The only two black holes are the ones at the side of your head, John.
Rabbit holes, black holes. Okay.
Yeah, I'll do that. I'll start talking science and I'm gone.
I knew you were going to. Anyways, this is probably a good point to stop.
Okay.
Unless you have any more questions.
I'll be quiet.
So,
By the
anyways,
way,
it is.
John, it was in Schaumburg, Schaumburg, Illinois.
There you go. Now he's gonna really do the research on this. Like I see it going.
Yep, you know it.
I see the gears turn, and it's like, oh yeah. Anyways, I just want to take a moment to thank everybody that joined us tonight in the chat room, and thank everybody that listened to us here on Spreaker tonight, and everybody that will listen to us out there in podcasts on iHeart, iTunes, and Spotify, and all the other ones that I never can remember. Thank you very much. And last but not least, thank you, Dr. Mark, for joining us this evening to talk about black holes and touch on some other things, too, that was kind of amazing that I just didn't really know about. Because John had a squirrel moment.
Not a problem.
Usually it's me, but it was him.
It happens.
All grist for the mill.
That's right.
So, anyways, I thanks very much for joining us. I hope sometime in the future that you can come back and we can talk about another topic because it really was fascinating to listen to all this.
Will do. I appreciate it very much. Thank you for having me, and thank you everybody for listening.
Well, I'll push the button.
Y'all take care. Thanks, John. Bye.